morning, guys. Today we're going to go over the midterm practice and work through some of the problems, as many as we can get through. Hopefully we can get through all of them. We'll start with this one. You guys can't see it, can you? Is that better up there? Hopefully.
I think you got some code on the top.
Oh, yeah, I've got the includes hidden. Okay. You guys are all sitting way in the back. Oh, it's not too bad. Yeah, there's include up there at the top. And here's the little bracket down at the bottom. We're just barely keeping up with. Okay, so the first question is on static versus dynamic scoping. Which one is the one that is the same as kind of we're used to programming with? Static. Yeah. So let's do that one first. The way that I usually do that one is I just kind of keep track next to the actual variables themselves. Because usually they're in pretty close proximity, other than the global, they're in pretty close proximity to the values to what we want to do with them. So on this one, K is global, and then we come into main and we set that global equal to 1. And then we call crackle. So crackle is up at the top. Crackle is going to print something out. So what's it going to print out here? What's going to happen? It's going to make K equal to 2 instead of 1. And then it's going to print out a 2. Perfect. And then we'll come back in and we'll go next to foo. Foo has its own K that it sets up, and it initializes it to 0. And then we come inside this scope, and we get a new variable again, find this 5, and then we call crackle. So what does crackle do? Does the global? Yeah, to 3 and then prints it? Perfect. Okay, and so that was this one, and then we go, now what is printed here?
0.
Okay. And that's from this 0 up here. This is no longer within scope. And then we call crackle again. 4, because 3 is less than 4. And then we call crackle, we come out and we call crackle a final time. 4. Yeah, no problem. And 4. That's it. Everybody good with that? Alright, now the slightly different one, dynamic scoping. In dynamic scoping, typically I just keep track of it over to the right somewhere. And in this case, we start with K. And it's equal to 1. And then we call crackle. So 1 is less than 4, so we increment it and we print it, right? So it's the same print. So we get 2 again. And then we go to foo. What should I do now? With this? Do what?
I mean, the first step is initialize a K, create a K to 0.
Create another K and set it to 0. So this is our current K right now. If we need to do anything with K, this is the K that we go to. Except we're going to do it again. So we set this K again, and we equal it to 5. and we then call crackle. So what's going to happen? I'm going to print 5 because it's going to skip that if statement. It's going to use the k from over here. And then we come back here, but we fall out, right? So we don't have this k anymore. And then we print 0, theory. And then we call crackle again. Yep. So this guy, that becomes a 1, right? And then we print a 1. And then that finishes us out here, and we lose, this guy falls off, right? So we won't worry about him anymore. We call crackle 1 last time. And we increment this to 2. Should have been doing this all along, but with the point. And then we print out 2 from right here. Cool. Any questions? Did I do something wrong? Is that right? It's good. And we return, and then there's the exit right there. Alright, moving on.
The last one. Because we incremented the first global variable, the first line, the first print is 2. In the first step, we incremented the global variable to 2 and printed that. The last line.
Oh yeah, that's why you change this over here when you do that. Yeah, you guys are right. So 2. So when we called crackle right here, when we called crackle from right here, we came in here and we incremented the global to the k that was up here. So I should have changed this 1 to a 2 and then printed it. That was this print statement right here. So then we fast forward to calling crackle again from right here, or we've gotten rid of all these k's that were in here, and we should have taken that and made it a 3 from right here. And then printed 3. That's why it's good to keep up with your tallies. That I didn't start doing. But that way you don't make that mistake. Are we good now? Perfect. Okay. Box and circle diagram. So this has got 3 parts. First part, we're going to draw box circle diagrams for P, Q, W, and X, and draw the star P, Q, and W at point 1, and then we're going to do the same thing at point 2, and then we'll list out some aliases. Alright, so you can't see the code. Are we good now? This old projector is always fun. Alright. So, this is P, since it was first. It's at memory W. I'm going to change this from the question, we're going to make it T. Just because it was X, and X gets confusing with this variable down here a little bit. So we're going to say that this is at memory location T. This next one is at memory location Y. And this one's at memory location Z. And then we have P, Q, on these. I just like to put it out there so that I remember, because pointers are always fun. Do ampersand P, ampersand Q. That was terrible. Just helps me keep them straight, especially if they do something with them or access them in some way. All right, so that puts us to right here. Q equals malloc. So what do I do?
Assign memory 1 to the first box.
To the first box, which is this guy, which is memory 1 right here. So put a 1 in here.
You just have to.
Oh wait, it's Q. It's not. Sorry. Go ahead.
Yeah, you have to put 1.
1 here. And then draw the line. So Q is pointing to box 1. The instructions for this say that all of these that are blank are equivalent to null. It's just easier not to put them in there for right now, so I don't have to erase them. But everything when it's initialized is a null value. So, and then W, kind of the same thing, except this is 2. We put a 2 here, right? Good deal. All right, where does the X go?
In the memory associated.
Yeah. Down here. Perfect, and then now P is equal to ampersand Q.
You just point
P points to Q, and we called that memory T. So I'll put a T there. Is that good?
Actually, star P points to star P. P doesn't point to Q, star P points to.
Yes. Like that. Right? Because P itself, we're changing the value associated with P to the value, to the address of Q, basically, which is T. So that puts the T in here, which means that star P takes this address and wherever it's pointing to. So star P is now going here. We also have star Q here. And star W. Comment? And just for clarity, we also have a horribly drawn star star P right there. So this is at point 1. This is what the box and circle diagram should look at this point. I'm going to keep editing this one instead of redrawing this whole thing. Is that okay with everybody?
So do we have to redraw it again in the paper?
Yeah, you'll redraw it again on the exam or when you're practicing. Because you need a snapshot there and you need a snapshot. The grader, whoever's grading it, whether it's Adam, myself, or the other TA, we need to know what you had at point 1 and then what you have at point 2. So yeah, you'll have to make a copy of it and then probably erase and mark as commands go on, but I'm going to cheat just to keep it all on one page for right now. So now we're going to set star P equal to ampersand W. What do I do?
So you swap change 1 to Y.
1 to what?
Y.
Y? Okay. Like maybe like that. Not very good, but you get the point. It's terrible. All right. So that means that we're no longer pointing here, right? and we're now pointing down to here. And that would be the star Q and star P, right? Cool. Any question? Everybody good on that? Now, star P equals X. What do I do?
Put C into the place where 2 was. So we have to change that X.
So star P, right?
To the memory.
X goes into the X.
Yeah, so I take this character X and put it into this memory. Is that what you guys are saying? Good? Everybody good with that? Alright. It's star P. And then, so that's pointing to 2. And then now we're going to take X and we're going to make it equal to the character P. That's just this guy right here, right? Make it P. And that's what we have at point 2. So what are some of the aliases that we have at this point?
Star P and
Star P and
Q.
Q. That's good.
Star P and W.
Star P and W. And
Star P and star. Star P and star.
what about one more for this line?
Oh, Q star W.
Perfect. Those are all equal, right? And we have star P, star W, star Q. Because it's a pointer to a pointer. So we can do that. I think I see any others. That's good. Questions? Okay. So on this one, if it's valid name under name equivalence, we write a 1. If it's valid under structural equivalence, we write a 2, and a 3 if it's valid under internal name. I did this when I took the test. You don't have to do this, but I just so I could remember, I said 1 equals name equivalence, 2 equals structural equivalence, 3 equals internal name equivalence, just so I could remember. Oh, and then 4 equals otherwise or error.
Does that mean none or 1 and 2 or
No, it means
just
none of those. If it's none of those, then technically, then it's a type error of some sort, so it's otherwise. So if something doesn't match up, then we make a 4. Alright, so instead of kind of trying to figure these out over here and what's equal to what at this point, I just kind of jump in with the variables and start kind of going back from there. So here we have a Q. On the very inside, we have a Q of 0. So it's a pointer, pretty much synonymous with array for what we're concerned about. So it operates the same, so we use the Q to return back a single value. And that single value is going to be of what type? Which struct? I. Exactly. So the type-wise, we have an I right now, and we pass that I into S. There's a typo there that's supposed to be a function definition with the greater than sign. So it's that's not wrong right there. But I can leave this up. Okay. So we're on S, we look at S, S takes in an H and then returns a D. So we have I though. Is I structurally equivalent to H? Yeah. Foo, int, first two, foo, D. D is a string, so this is basically a string, so you have int, string. So that's good. And then what does S return? S returns a D, which is of type string. What type has to be inside these brackets for array access? Int, exactly. But we have, so what's our answer?
4.
Yeah, exactly. 4. You wouldn't have to write this, but just so we're all clear, it's a type error. Because S returns type D, which is a string and not an int, we have a type error.
Should we show a table of structural equivalence table?
Not for this one, but for the next one. You don't necessarily have to do it for this one. Okay, this one looks a little simpler. We have Q going to 0 again, so a pointer to I, and then Z is type H. So are I and H structurally equivalent? Yeah, we already kind of figured that out, right? So what do I put here? Is there a name equivalence? No. Structural equivalence? Yeah. And then is there? There's no I and E, right? There's no internal name equivalence here? Perfect. Alright, now we got P and Q. It's these two guys. They're on the same line, which is a huge hint. Yeah. And? Name equivalence? Do they have name equivalence?
Yeah, because it's type I is a
But it doesn't have a name.
So let's back up. Is pointer to int, is this right here, is that an anonymous type itself?
Oh.
Right? There's no, it's not tied actually to any. Yeah, I know
Yeah.
it's so nitpicky, but that's the whole point of the internal name equivalence. It's when two on the same line get assigned to anonymous type, the compiler itself, magically behind the scenes, says, oh, on name equivalence, I don't know if P and Q are actually the same. I'm going to create a type for P and a type for Q with totally different, random alphanumeric string that I assign that to or whatever. That's kind of how I envision it. And so they're two totally different types as far as name equivalence is defined. But under internal name equivalence, we gave the compiler a little bit more intelligence and said, no, they're on the same line, even with anonymous types, they're really the same thing. So yeah, definitely we've got structural name equivalence and internal name equivalence, but no name equivalence on that one.
But if it was just I, it would be name equivalence.
Yeah, because there's no type. Well, no.
Do I the type?
Yes. Yeah, it would. Yeah, it would. Yeah, because you've defined a type I explicitly, and I's on the same. It's already got its number. This is an anonymous declaration over here, but now we're assigning both of them clearly to just that one single hidden declaration or whatever. So yeah, that would meet name equivalence. And then we have x equals y.
That's an error.
Sure enough. It is an error. We've got X is a D, which is a string, and Y is an int. That's pretty clear for type error.
So we have two anonymous types. One is pointing to something and one is array of something, right? Except for that, do we have any other anonymous types?
Well, this struct would still be an anonymous type.
Yeah.
Right? So that's another example. I think those are the only real examples you'll see. A function declaration could have, could be an anonymous type too. Anything that's kind of more than just a basic type could be could have an anonymous aspect to it. Cool. All right. Now the next part. We want to know if D, H, and J, what they're structurally equivalent to. I'm actually going to do this. Make this a new work area. Okay. So for each of these types up here, we want to find all the guys that are structurally equivalent. That's no good. Oh, because I'm inside. That's not what I want to do now. Oh, it did. Cool. So what we do on these is we start with each of the letters. You don't necessarily have to do it for the basic, the ones that are directly to a basic type, the D and E. I just feel like it's just a good place to start. The assumption here is that in all these boxes we have they're defaulted equal to true. So before we even start,
Is he going to ask for a chart for the midterm?
I don't think you'll have to do the chart, but the way I've always seen him answer these is with a chart. And they can be, this one is not particularly complicated, but they can be more complicated than this, and then that's no fair. Oh, highlight the whole row?
Yeah.
And then it'll replace it for me. One note. So yeah, it was. You don't have to do this. I just thought it'd be, just to make it very clear. I'm going to end up hating that I did this, though. The first thing I'm going to do is put in a bunch of falses. Wow, quit it. Okay. So we default everything's true. Make it all fancy and highlight it, or at least make them bold. So D is a string. All these other guys are structs, so it can't be equal to those, and it's definitely not structurally equivalent to that. So we actually, like I just said, that's actually not bad. So I want to do this. So that one's done. Now we've got E, kind of the same deal. All of these are always going to be structurally equivalent to themselves. That'll help you remember that you need to write the letter itself on each of these rows. included. That's why it says including the type itself. And then now for E is not a structure, so it's not going to be equivalent to any of those. And now we're basically just working in this block, which is kind of why I think Adam said that you can leave those off if you want. Leave the D and E off because they're pretty obvious. And they're going to be pretty obvious on the test. This is probably at max most redefined basic types that you're going to have is 2. But anyways, so now let's start with H. Which one is H structurally equivalent to I? Yeah, we kind of already did that. So we know that's true. I don't have to do anything. How about J? Is it structurally equivalent to J? No. And K either, right? This K kind of looks like J. Now we did I. Right, so we can kind of shorthand, we can just do it real quick. Because since we know H is equivalent to I, we can just basically copy the same thing. That was more for the people listening at home. All right. So the last one, we're on J now. Is J functionally equivalent to K? I'm sorry, structurally equivalent. Wrong word. Is it structurally equivalent to K? So we've got a pointer to I and a pointer to H. I and H, we know, are structurally equivalent, so therefore this pointer is structurally equivalent. And then we have Y goes to E, which is an int, and Y goes to int, which is an int. So yeah, those are structurally equivalent, so we get a true there as well. And then, of course, K is structurally equivalent to K.
So if I and H weren't structurally equivalent, though J and K wouldn't be.
Would not be.
Okay.
Right, exactly. So say that J pointed to J was, to itself even. J was to J. Are J and H structurally equivalent? No. And so therefore J and K couldn't be structurally equivalent. To have a really confusing example. We good on that? All right. Now the monster. This one's relatively tricky, but the key here is to focus on the level that you're looking at and not looking at anything else, especially when we get down into the more complicated parts. The other thing is you can go in pretty much in any order you want, as long as it's just, as long as you only consider one segment at a time. It doesn't really matter what order you define stuff in. So what I've done, which is a little bit different than I think he did it this semester, I define these guys out here to the right. And I have TB for B for the type of B, TC for the type of C, and TD for the type of D. And then TF is actually for the output of F, so whatever type comes out of F. And then T1 we might use later. So I want to move it back here. So to start with, do we know much at this point? Just looking at this top part. Oh no. So I'm going to erase mine. We do know one thing. What is the type? So this is function definition. What is the type over here that we came up with? What's coming out of F? What type? T of F. It's the worst T of F. There we go. So we have T of F that's coming out of here. Now we're going to look at just this level. So what do both of these, what do they have to be based on the plus sign? Yeah, they have to be the same types, and they have to output the same type. So what type are they? T1 or T of F? T of F. We don't really know that much else at this point. I mean, we do kind of know that T of F is either going to be an int or a real, but we can't tell beyond that. We don't have anything that tells us whether it's going to be more than that. So let's go over to the left-hand side first. And now we're going to look at just this level, this middle level right here. So we know that this is T of F. So what is this down here, right here? Well, we know it's T of F, and then this is an array operator. So what's C is an int for sure. So type C, if we know for sure that type C is an int over there, right? And we know that this one has to be as well, and this one. Cool. Now we have, what is it over here when you have an array? Don't look at apply. Don't look at any of this. What is it? When we have an array operator, what do we have over here? It's okay to be wrong. What's that? So this, don't worry about the apply. Don't even look at, pretend like, yes, exactly. This is going to be terrible, but it'll be close enough to figure out what I was writing. So it's an array of T of F. The constraints dictated by this type that we know up here and its own type. Okay, now we look at the apply. And we know that this is telling us that, it's B. So we're concerned, one of the things we want to figure out is the type of B. So what is, based on an array of T of F and this guy, what is the type of B? It's a function. So it's going to look something like this. Yes, exactly. So it takes in an int and it returns array of T of F. Everybody good with that? So now we'll come back over to the other side of the plus sign. We know that at this level it has to return a T of F. I like to, because these multi-level ones are tougher for me to conceptually just think about, this is where I use that type 1. If I can find my cursor on the screen. So just for kind of a placeholder in the interim, I say, well, I don't know what this type is, but I just want to, right now I'm going to skip down and just look at this so it's nice and simple. So which type is defined right here? We do get a type definition of which variable or which type. D, yeah. So D is going to be some kind of function definition. It's going to output, it outputs T1. And what's its input? Type of B. Right? So B was its input, and then we're only concerned about types. What is T of B equivalent to, or what is it equal to? This monster up here, right?
know the test can we write TB instead of that, or does he want it to be the entire?
Oh, that's not. There we go. Say that again.
So on the test we write TB instead of the entire, right?
I would write the entire thing. I would write the entire thing. I mean, you can. It'd still probably be marked right, but
Be careful.
it's clear. It's just clear what you know what's going on instead of writing the TFB. So T of D is defined with this T1 coming out of it. And then now we can look at this apply. So we go up a level. Which type is this apply now defining? That's on the left-hand side. Yeah. Yeah, exactly. Takes an int and returns
He returns it TF.
TF. Perfect. So we took care of this int, got the T1 defined. Now, for clarity, we can replace this T1 with what we know. At this point, which is that this function returns itself another function that takes in an int and then returns TFF. As far as I can tell, and this is the second time I've worked through this in front of a class, TFF doesn't have a basic type. We can't figure out a basic type for it. It's not restricted in a way, so it's blank at this point. It's TFF. And so we leave all the TFFs that are already up there. What we do know is that they all have to be the same. So if we did figure out one form of TFF, and we also know that it's probably a real or a, well, no, we don't know that actually. I think depending on which language we're using, you can add strings in a bunch of languages. So I don't even think that's necessarily a restriction.
Well, we know it could be another function.
Yeah, it could be. Could have two functions where you add one another, and that's the really sneakiness of all of this. But what we do know is that whatever it is, TFF is going to be the same in all these different spots. So if we do figure it out, we have figured it out everywhere. Are there any questions?
So do we have to write a type for function also? The topmost level?
Do we have to what?
To write it in the same format for fun also?
Yeah, so on the actual question, it asks for the types for TFB, TFC, TFD, and then the output, yeah, so TFF as well, or the function F, basically. I'll show you. Yeah, so down here, oh, it does ask the type that F returns. So are we missing something?
I think you could just leave it as TF.
Based on the other ones, yeah. I need to double check that, but I think that's right. I feel like it's right. Type of B, type of C, type of D, and then the type that F returns. And part of the reason he says it this way is so you don't have to write out, because that would be a really long function when you start replacing. But you'd have to you know, the B here with this, and then the C here with int, which is fine, and then the D here with int of array, or blah, 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 and then goes to TFF. I don't see any way to determine that beyond TFF.
So what is function returning? Is it returning E of f?
Yeah, it's returning TFF. It's returning some type. We don't know which specific type that's similar to all these other types. Or it's the same as all these other types. So this function better is returning the same thing as the f. Questions? Other questions?